Hello everybody, welcome to Virtual School Physics is Fun. This is Puan Liao. Today we are going to learn reflection of waves. Wave is reflected when it strikes an obstacle. So after reflection, the direction of wave changes. The law of reflection says the incident wave, the reflected wave, and normal, all these three lies on the same plane. And the angle of incident I equals to the angle of reflection R. Let's view this video to study more about reflection of waves. Okay, this is a Ripper tank. We are going to study reflection of water waves. So as an obstacle is placed inside the Ripper tank, here you go, obstacle. So you can see that the reflected wave and the incident wave form a square. Okay, this is the incident wave and the reflected wave bounces off that way. So they form a square, right? So the incident wave, this is the wavefront of the incident wave, and this blue one is the wavefront of the reflected wave. As we can see at the region where they meet each other, you can see squares. All right, so what does this square means? So this one is the wavelength of the reflected wave, and this is the wavelength of the incident wave. And the square tells us that this lambda 1 equals to lambda 2, meaning to say reflection does not change the wavelength, right? Incident wave and reflected wave, they have the same wavelength. So reflection changes the direction of wave, but the wavelength remain unchanged. Okay, so let's look at the characteristics of reflection of wave. In a reflection, frequency, wavelength, and speed of the incident wave and the reflected wave, no change. Frequency, because frequency is affected by the vibration of the motor. Remember? Okay, direction changes because wave bounces off to the other direction, and velocity changes. Why? Because velocity is speed and direction. So even though speed does not change, but the direction change, therefore velocity change too. Application of reflection of waves. Let's look at water wave. Water wave is reflected, okay, by high concrete and rock walls which are erected so that erosion does not take place. Okay, so this wave breaker prevent the wave from spilling over behind the wall. So as you can see from the picture here, behind the wall the waves are more calm. Now, radio waves in the telecommunication satellites are reflected by parabolic dish so that it is focused onto the antenna. Okay, so where should the antenna be placed so that the antenna receives maximum reflected wave? Okay, let's look at this diagram. So this shows a concave reflector. So waves that comes parallelly will be reflected towards the principal focus or the focal point, right? So if we put the antenna here, so waves that comes very far, it all comes parallelly, so they will all be reflected at the focal point, which is where the antenna and the receiver is. Therefore, maximum wave is received. Similarly, a transmitter that transmit radio wave to the receiving tower. Okay, so the transmitter is also placed at the focal point so that waves that originate from the F, from the focal point, is reflected parallelly. All waves that originate from F will be reflected parallelly, and parallel rays will travel very far. Now, application of reflection of sound waves in an auditorium. Yeah, the ceiling of the auditorium is made into a concave shape. Why? Because concave shape will reflect sound wave, not only reflect, but it will converge the sound wave, yeah, back into the hall so that the audience can hear very clear sound. All right. Now, in the ancient time, when there is still no electricity used, so there is no loudspeaker, there is no Wi-Fi, so uh, there is no hi-fi, so they built their theatre in a circular shape, either half circle or full circle. So, like what is in Colosseum, the famous Colosseum in Rome, Italy. All right, and this is another amphitheater in Turkey, which can seat 25,000 people. It's very huge. All right, so when I went to Turkey many years ago, I asked this my tour member to stand at the stage here and sing with normal volume, and we all climb very far up, right? As you can see, the size between her father and her is she's so small. So that tells us how huge the amphitheater is. Okay, so we are all at the back here, and when she sing, we could hear her very clearly. So it shows that the acoustic of this amphitheater is very, very good. Yeah, because the amphitheater is in a concave shape, so her voice is reflected. Right, it's reflected back to all the audience. Now, when you were small, even before you were born, some of you may have a photograph of you taken. Yeah, your mother uh, will be very happy to see your image. Yeah, your image even before you were born. All right. So this technology is called sonogram. Yeah, sonogram used by doctor to check the fetus of a baby or even to detect any growth in a patient's body. So all these are application of reflection of sound waves. Bats. Bats are blind. Bats live in a dark cave, so they do not need to see, but they constantly produce this jizzing, this sound that is reflected. This chi 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 sound that is reflected by the wall of the cave and also by their prey. So with that echo, so the bat can estimate the distance of the wall of the cave and also the distance of the prey from the bat. Okay, so sound wave is also used to estimate the distance between two objects. For example, a cave, a well, or the width of a valley. By means of echo, so we are able to estimate the distance between these two objects. Yeah, the depth of a well or the distance of a cave. Okay, let's look at this technology called sonar. Sonar stands for sound navigation and ranging. Right? So the fishermen install a transmitter that can transmit high frequency sound wave into the sea. And the sea bed reflect the high frequency sound, and the reflected wave is received by the transducer. So the time difference between the sound sent off and the sound received enables us to calculate the depth of c. By using this formula of speed equals to distance over time, so we are able to calculate the depth of c. But bear in mind, here the time has to be half, simply because sound wave is sent into the sea and then reflected and received by the transducer. So the time difference is shows that the sound wave have traveled to and fro. So, but we are only calculating the depth of one distance. Therefore, we need to halve the time. Half the time that the transducer detects. Okay, let's look at this question. Okay, an ultrasonic wave is sent out by a ship into the seabed, and the speed of the wave is 1,500 meter per second, and the time between sending of the wave and receiving of the wave is 0.06 seconds. So now we want to estimate the depth of C. So using the formula speed equals to distance over time, don't forget time you have to halve it. So we substitute the speed of wave and the time taken and halve it, so we can estimate the depth of the sea, and it is 45 meters. What about this second question? So this ultrasonic wave has a frequency of 25 kilohertz, and the speed of the wave is 1,500 meter per second, and the time between sending of the wave and receiving is 120 milliseconds. Determine the depth of sea and the wavelength. So A, the depth of the sea. So we substitute in 1,500 times 120 times 10 to the power negative 3. Why negative 3? Because millisecond, we change to second. So half, then that gives us 90 meters as the depth of the sea. As for the wavelength, we use the equation V equals to F lambda. So lambda will be equals to the speed of wave divided by the frequency. So 25,000. So that gives us 0.06 meters. Okay, so I hope you have learned the reflection of waves and the application. Okay, so that's all for this topic. We will meet again some other time. Thank you.